Hello everyone. Welcome to another episode of Electric Power Syrup. In this episode, I will be showing how to create a 3-bus case in PSSE from beginning. In order to do so, I will be using the following 3-bus example. This example image, the final files, and the parameters used to create this example will all be shared. Please check out the link in the description of this YouTube video. Let's get started. For our ease, I will be showing the parameters of each component as we make progress on the right hand side of the screen. Let's go ahead and launch our PSSE if you have not already done so. A very first step I would recommend to do in any PSSE analysis you do in the future is to start recording your actions. This can be useful in multiple ways. You can easily retrace back your steps, what you have done. You can use the commands listed through this sequence of actions for your Python automation scripting, which we will get to in future videos, and you will see how impactful and very useful this feature can be. So I'll go ahead and click on this red small button to start recording my session. It basically saves every action you perform in a Python script or Python file. So I'll go ahead and save it as 3-bus save. Then let's go and create our new network data. So click on file, click on new button, and click on case data. You can leave the default parameters or modify. For example, if your frequency is 50 Hertz, make sure you select or update this parameter to be 50 Hertz frequency. I will leave it default. Heading, I'll just put 3-bus case. Click OK, and it will create this network data, which is empty. It's an empty data structure. The next step I'll do is create a new blank slider diagram where we will do our 3-bus system creation by drag and dropping the power system components. So I have created this new single line diagram. I will go ahead and save this single line diagram so that we continue saving our file as we make progress to not lose anything. So I'll give the same file name 3-bus save. One important thing to make sure here, right click on your mouse and make sure this bind items is checked. If not, do select and make sure it's check marked. What this means is any changes you do on this slider diagram will automatically be reflected in the network data file. And I'll show that shortly as we add some components. So let's move ahead to start adding our first component. We will begin with adding all 3 buses. Just to recap, this is how our system looks. So we have 3 buses, 2 generators, 3 transmission lines, and then 1 load. So let's first add our buses. In this toolbar, this vertical black line you can see, so that's your bus bar. So select that, to your mouse. Click anywhere on the white space area, left click your mouse, drag, and then drop. Or you can just click and just click drop. The bus number 1, as you can see, is our Slack bus, which is also known as type 3 bus in PSSE. So bus number 1, the bus name I'll just put bus 1. Type code, as you can see here, select the 3 swing bus because that's the Slack bus definition in PSSE. And our base voltage for all buses in this case is 345 kV. So I've updated that value and click OK. So rest all you can leave it default. So you can see a bus has been added. Again, so I'm still in the bus bar selection. So I click anywhere on the white space and another bus will get added. I'll go ahead and add our bus 2. So bus number 2, bus 2, and bus 2 is our PV bus. So it's a generator bus, but it has generator, but it's not our Slack bus. So it's a type 2 bus, which is generator bus. I update my base kV, which is 345, and then click OK. And finally, I'll add another bus. So I just do another click. Bus number 3. This is PQ bus. So the type code is non-generator bus. So you can leave it as it is. Update the kV 345 and click OK. The next thing to see is you can navigate on the screen. So, but to do that, you need to get out of this selection. So there are 2 ways. One is you can click on this mouse pointer select button to get out of this component selection. So you can click on this mouse, or you can press escape key on your keyboard. So you can see what happens when I press escape key, and you can see it moved to the mouse pointer selection automatically. With this, you can move your slider diagram left or right, select a component, you can drag or rearrange its position. So I'll just rearrange that to look somewhat similar to what we are trying to achieve, which is this 3-bus system. The next, I have generators here, but we'll do that at the end, generator and loads. Let's first connect all these 3 buses. So as you can see on the right hand screen, you go back to the toolbar, and just beside this small black dot, you will see something called branch. So this, as you hover your mouse, it will display this useful information, what each of this button is about. So you can see it's branch. So select that and you can see it's selected. Now for branch, you need to select the first bus and then the second bus where you want to add the branch, but you should not let go of your mouse. So basically, I bring this plus sign to bus 1. I left click, but I keep holding my mouse, drag all the way to the second bus of that branch, bring that plus to the bus 3, for example, and then leave. And you can see this branch data record will pop up, and it will automatically have your from bus to bus and information field. All we need to update for this one, so here we can see line 1 to 3. Length is 200 kilometers, so I'll just update length as 200, and then R value is 0.0062, and then X is 0.0632, and then click OK. The rest all you can just leave it default. These are the minimum parameters useful to perform our power flow analysis. So click OK. This is just a message since we updated the impedance values of this branch. So it's just saying that your branch is no longer a zero impedance branch. So you just click OK and that's it. This branch is added. So we'll continue this step. We are already in the branch toolbar option. So next I'll add is line 2 to 3. Same thing. I come to bus 2, click, drag to 3 and then leave. Oh, sorry, I pressed escape, so my branch got deselected. Deselected, so I'll select my branch again. So click on bus 2, drag and then drop at bus 3. This is 150 kilometers and then R 0.0047, X is 0.0474. Click OK. OK. And then finally branch line 1 to 2. So I'll select again bus 1, click on left bus 1, drag it to bus 2 and it will pop up. Same thing, I will update my length 150 R 0.0047, 0.0474 and then click OK. OK. So we have now added 3 buses and 3 transmission lines. The next step is to add our generators and loads. So let's go back here on the data. So let's add our first generator at bus 1. So to do that, you will come back to the toolbar. You go to this circle with a line. It says generator. As you hover your mouse, select that. Go to the bus where you want to add the generator. Bring the plus sign on that bus. Left click your mouse, drag and then drop. It will say the new plant created at bus 1. Change the bus type code to 2. I don't want to change. Remember, I already defined the bus codes when we drag and drop the buses. So I don't want to change the bus code. I want to keep this as swing bus. So no. Then it will pop up the generator. Since this is our slack bus or swing generator, we don't need to define our P or Q, anything. Only thing I will make sure is the voltage regulation is set to 1 per unit. So I just come in the bottom right and you can see the plant data. It is set to 1 per unit. So I click OK. The generator is added. I'm still in the generator mode. So I come to bus 2, select, drag and drop. New plant created at bus 2. Again, I don't want to make any changes. Although in this case, it's already 2 and then it's asking again to be changed to 2. So even if you click yes, it shouldn't matter. But then as I mentioned, we have already defined the bus codes when we were defining the buses. So I'll just click no. For generator 2, we need to define its active power output to be 200 megawatts. So I'll go to pgen, update to 200 and then schedule the voltage to be 1.05 per unit. So I'll go here, scheduled voltage 1.05 for bus 2. You don't need to modify or do anything, any other parameter for this particular case study. And then I'll just click OK. So the generator is now added. And finally, we need to add our load. So for the load, it's just beside this generator button with a downward triangle and a line. So select this load, same thing, bring your plus or mouse pointer on the bus where you want to add, left click, drag and then leave. So it will add this load. So load, as you can see, we need P load active power to be 500 and then reactive power Q load to be 100. You don't need to change anything else. Leave it as default. Click OK. I'll just switch to the arrow mode so that I can move this load to other side, just for beautification, to make it less crowded on the left hand side. So now you have added all the components. So I'll go ahead and save my slider diagram. So I can do that, as I mentioned, go to File, click here, or you can use the keyboard shortcut Ctrl+S. Now, as I was mentioning, as we were doing all this adding of components, these were getting added to our network data. So as I switch to network data, you can see this bus, plant, machine data all getting popped up. So if you also have this, and this could be because of the screen resolution, so it's like an Excel table. So just come here, your mouse, and when you see this line with up and down arrow, just select that and drag, and it will expand. So similarly, you can expand your columns or rows. It's like an Excel table. So you can do that to have a clear visual. So this is your bus information. We have added 3 buses. So you can go to load. So you can see we have 1 load defined. Then you can go to machine and you can see there are 2 generators. So I'll just give you a quick difference between this plant and machine. What happens is, in practical power systems, in one area you may have multiple generators. To define that exclusively, so you define like a one single plant, like your substation or a single location, and as a single bus, and then that will have multiple generators on that same plant. So you can define like 3 generators over here, but it could be part or located at the same single one plant. In our case, we have 2 different explicits, so both are same, but just wanted to tell you quickly the difference between plants and machines. And then your transmission line data is located in this branch tab. So you can go here and you can see we have 3 transmission lines added, and you can see their R, X value. And as you can see, I can click on this table and make changes on these values. So you can make changes here directly as as I said, it's almost like behaved like an Excel file or Excel table. So all this is done. So I have saved my slider diagram. So let's go ahead and save our network data file. So I switch to network data, click file, and then I can do save file as. You can see there are multiple output formats. I can save this network data. So some of this is described in the bonus chapter or the book, where I define what these different file formats of PSSE are. You can check it out in the book, or I will cover those things in detail in the future videos. But for now, just make sure you are in the PowerFlow raw data tab. You can click on these 3 dots to select where you want to save. I will just use the default location, but you can save anywhere you want. Give the same file name 3bus, and you can see the save as type .raw file, and then click on save. Okay. So this now saves my network data, and then we have single line diagram. Now we are ready to perform our PowerFlow analysis. I have explicitly covered in another video how to perform this AC analysis, you can check that out, but I'll quickly show. So I'll go ahead in PowerFlow, solution, solve. I will leave everything default. I don't want to change anything for this analysis. Click solve. And you can see the PowerFlow converged or reached the tolerance in 3 iterations in the output area. Now, to enable the animations, you would see those buttons in this toolbar on the right hand side. But since I have reduced my screen size for PSSE, those got hidden in this small drop arrow. So if I click this, it will show me these options. So you should see the same symbols. So I'll click on animate flows to see how the power is flowing. And as you can see, this solution will closely match with what I have in the picture. For example, this line 2 or bus 2 to 3, 268 megawatts of active power is flowing and 147 reactive power, and you can see this visually here. So this is how you create your any power system network from scratch. I hope this gave you a good idea, and there are a lot of different components your system may need. For example, you have more induction machine, shunts, then your fax devices where you define your uh, like SSSC device, STATCOMs, or even the HVDC lines. This is your transformers. So you have a lot. Sorry, the HVDC will be here, two terminal DC. You have VSC DC line. So facts can be also used for UPFC device. So there are a lot of more components which you can add, which would probably you would need for more complex system than this 3-bus case we just showcased. But I just wanted to show you overall approach, a general idea of creating the new files, single line diagram, drag and dropping your components, defining the parameters, and finally running the power flow. So with this, I can stop my record button. So that will save all the actions I have performed. I'll quickly show how that file looks like. I'm browsing through and I'll just show how the contents of the Python file looks like. Just to give you an idea. Example. Okay, trying to find where did it save. Bus. Let me check here. So files, save as. Okay, so I'm just trying to locate. Oh, okay, I found it, and yeah, this here. So you can see this Python file which we defined at the beginning. It saves all the actions we have performed, and we'll show how this can be very powerful or useful to you in many situations. We will cover that in another video, but just wanted to show you this contents of this file and recommend you to always start recording your actions when you begin any new analysis or any new work as you launch PSSE, and that will do wonders for you. With that, I hope you liked this video and learned something. We will come back with in the next video, which is actually a continuation of this, where I'll show how to generate different power flow reports and some visual other voltage contours and stuff, some bit more fancy things you can do with this power flow analysis. Till then, take care, and please don't forget to like, share, and subscribe to stay tuned with all the latest content on this channel. And if you have any request for any particular topic you want me to cover, do let me know through the comment on this YouTube channel, and I'll try to add that to my list. Thank you so much. Take care.